And we are on the sea floor. Looks like a sedimented area, similar to what we were seeing yesterday.
We'll stop the wind shear. Great.
And it looks like we have our first fish in sight.
Copy that, thank you. And I want to let you know that we have just arrived on bottom. So for a bailout plan, let's go ahead and set.
How's that video? Check. 1, 2.
All right, thank you.
Check again.
And just to re-verify, because it's on my checklist bridge,
so the depth here is 3,425 meters.
Great, thanks.
And we get swing arms out, Sean? Yeah, go ahead for swing arms. Watch leads, we just got to bottom, and we just need several minutes to set the vehicles up, and I will let you know when we're ready to start the dive.
We're going to be here a few minutes as the ROV team gets set up for the dive. You can see that on the seafloor in front of us, any little protrusion from the flat landscape ends up having a little sedimentation, a little mound of lighter sediments behind it. So you can tell that there's some current in this area.
Slight current pushing back.
That lighter material is recently sort of blown sand that came from the top of the screen toward the bottom of the screen.
Sorry, Wash 1, did you hail pilot? Oh, sorry.
Go ahead.
We're expecting to find
I'll copy that.
some considerable currents at times here. We are underneath a major current of the North Atlantic Ocean called the Western Boundary Undercurrent. It's a colder current coming from the north, flowing southward. Very different from the Gulf Stream that is near the surface, of course, and quite a bit farther to the west.
Because I keep going, so you might still be moving a little bit.
Yesterday's dive, we already began to feel the effects of the Western Boundary Undercurrent, noting that it was colder.
Light configuration.
And
do you want to push draw in real quick?
We were shallower then, so we're in more of the zone that we will expect to find stronger currents.
Perfect. All right, video. Did you have something for nav?
So we're seeing a little bit of indication of that current.
I think we're good. Z-bar
how's this right now?
Put in. All right, I'm happy with that.
Testing. 1, 2, 3.
All right, watch leads. We are set up, so I will continue the dive, and just let me know if you want zooms on anything.
And we've just learned that we're all set. We're going to
you in to 50.
Begin the dive.
Yeah. Co-pilot, what do you want? You're at 50 right now. You want 30?
50's fine.
No. I'm sorry, pilot.
So the first fish that we saw when we reached the bottom
30's great.
might be Coryphaenoides. Daniel Wagner ID'd that fish.
And then what approximate direction are we moving towards? Is it just upslope?
And I think that the fish fauna are going to be quite interesting at this depth, so we'll need some help from scientists on shore with the fish here.
254 copy.
Oh, pretty close.
Yeah, that's great.
So I said you're right on.
Nice job.
That was you.
Oh.
Good job.
Thanks. I tried pretty hard.
So this dive is especially interesting for scientists because this area is so underexplored that everything down here is a big mystery. There's some reports of a fair amount of life, and there usually is, even at depth. But the escarpment feature is quite unique for this whole broad area. So we're excited to actually see what's there and ground truth it.
Barren.
Sure. Yeah.
Looks like
you guys ready to go already?
Rear of the ship.
Yeah, Copilot's ready for move.
Okay, how about 254?
We're seeing some evidence of organisms that are probably grazing the surface or just below the surface. We saw these yesterday. Those are the track marks.
And for next
Scott France believes that these are related to heart urchins.
Try to track layback for next.
Yeah.
I saw the shell of one yesterday. It was no longer alive,
like
but
10 minutes
that
maybe.
sort of
I don't know.
potentially confirmed Scott's idea.
Jellyfish and Sirius. And see him?
Ray, driving nav.
Still guy?
Hey, we're ready for our first ship move. We're going to go 30 meters at 255 degrees, 0.2 knots. Correct. Any current?
A little bit downslope, not much.
So west to east.
What we're hoping to encounter on this dive is hard rock exposures that would provide a suitable substrate or seafloor on which invertebrates can grab a hold.
Still on screen.
Just
These sessile organisms need something that doesn't migrate like sands, that would shift due to currents. And once they find a home like that, then they become sort of central locations for other invertebrates to commingle, I guess you might.
Yeah. You can come out and I can get a little closer. All right, I'm gonna kill
So
lasers.
let me know when you start moving there, co-pilot.
All right, come on in, video.
Understand.
Sorry,
I'm not sure what this is that we're zooming on. If it's an octocoral.
It's Maxim.
Not sure.
Not the best angle, huh?
No, it isn't.
Pretty small subject.
Yeah.
About fog lights.
Trying to get some stuff kicked up too, so it may drift in.
So as Leslie said, even the smallest rock or hard surface will be colonized by something, and I believe that might have been a small octocoral, but I couldn't quite make it out.
Yeah, my starboard just
if anybody has any ideas in the chat room or the phone, please let us know. There's also a Serianthid tube worm
Very soft bottom.
right far of the skid of the ROV now.
You get lasers real quick, Copilot?
Yeah, sorry.
There you
Was that an enemy?
Yeah. All right, you can kill lasers.
It's a tube anemone, sorry, Serianthid tube anemone.
Got those fog lights on? Two lights that
do we usually use them?
It'll depend on your zoom and like if there's shadows up in there.
All right, video, go for zoom. Let's see.
This is
Kick on the extra lights.
it's a good position for them. That's where you'd want it.
Yeah. Ooh.
Yesterday I suggested to Cheryl that maybe we should collect one of these, and
help her
she laughed.
Was
What
good,
did you tell me?
Yeah, the tube
And
extends
then
quite far
you
into
can
the
rotate to
sediment,
keep you in view.
several feet at least.
And I'll come back center after this, Copilot.
With just a manipulator arm to grab it, I don't think there's any way that we'd get the tube out.
Completely disappear.
In the Johnson Sea Link, we spent a fair amount of time collecting one of these with the suction sampler.
In the nips, you can see the current when it's
and
going.
Clear.
Great.
Probably
Come
was
on,
about a
video.
half hour worth of work to get it out.
Nice job,
Did it work?
Copilot.
You got it?
We did get it, yes, but going back to that first organism that we looked at, the little white organism on the rock, Daniel Wagner
255
suggested
is
that it
cool.
looked like a sponge, and Scott France suggested
there you go, there's a
possibly a sea
starfish.
pen.
Right there on the lasers.
Kind of, nobody is certain.
Video's calling it a coral.
And that's just a good reminder
Right,
of
kill
why
lasers.
we do collections.
Video, go ahead, come in.
You can often tell a major group of organisms what it is. You can often tell down to a genus, get a genus ID, but when you get species level IDs, often the characters that are species specific require a microscope to look at them, being able to turn an organism over and look at each side, counting very small features that we just can't see in this video, even though the video is absolutely amazing.
We've zoomed in on a brittle star, and we had the great pleasure to watch one of these in flight, a swimming brittle star. And most of us on the line, if not all of us, had never seen this. And overnight, we heard from Tara Luke saying that there has been a paper documenting ophiuroid, which is brittle star group behavior, including swimming.
Video, come on.
Oh,
great to hear that others have observed.
Roughly where he is, I think.
Documented it.
You can test it, and you can bring it up on one of these monitors and see.
Right there, now down.
Copy that. Thank you. Have you started moving yet?
Not yet.
Okay.
Given that that paper was from 1991 or something, that's probably still a fairly rare sight.
Pretty rare. And I'll bet it's never been videotaped.
Yeah, especially with this awesome video that we have here.
Video.
You'll see it in a highlight video soon.
Yeah.
In a theater near you.
Oh, barnacles.
Can I take monitor 12?
Absolutely.
You can see their feeding appendages out. And that looks like it might be some sargassum caught up in.
So once you turn it on, it'll start getting you.
So
you have to actually take pictures with it
sargassum
first.
that was on the surface at one point.
It's very tiny.
I think it's
is that
lost its flotation.
Lost its flotation. And then it becomes food for the benthic organisms eventually.
Oh man, I'm not even seeing it.
We are on the edge of the Sargasso Sea, and as we cruise along at the surface, you see a lot of these float by, and they become microhabitats for the surface organisms.
All right. We have a different lens on there.
We had confirmation from the chat room. Tom said that yes, this is sargassum, and there were also bryozoans.
Can we put that back on?
In that little clump of life.
On the tether, so I know. Perfs.
I've got a quick button over here for the still camera to put it on this monitor here.
Oh, okay. I have it off right now. So yeah, Roland, what are the operations for that camera? Do you have to make adjustments on it, or do I just hit go?
You just hit go.
Okay. The pictures that I saw were pretty dark.
We have no control of them once we're off deck.
Okay. Some rocks just hanging out.
I'm getting a look at a few little rocks poking out of the sediment.
Something white. Diagonal up from lasers.
You can see the downdrift side of these.
Looks like we got something.
Anything that sticks up into the current
from you
causes deposits of material behind it. You can see a sponge there as well. We're going to take a look at that.
Copy that. You want to kill lasers, co-pilot?
Lasers coming off, lasers off.
Yeah, watch one, go ahead. Absolutely. Video.
Interesting to see such large grains here. We'll see how big once we get the lasers on.
Slight tilt up.
Try the extra light on this.
Nice.
Roland, if you'd rather, we could leave it on too.
No, we can't keep it on because it adds
it's not real good to fly with it.
Okay.
Reflection.
Understood.
For anybody who joined our dive yesterday,
you're
sponges
moving,
were the dominant organism when we got to the rocky outcrops.
Yes.
And I'm not sure that this is
under
the same
9
species.
minutes.
And hopefully Shirley Pomponi might be able to join us and help with the sponge IDs or anybody else. But yesterday's sponges were dominated by one that looks kind of like a
We got a fish directly
We had
behind.
lasers one more time, Copilot.
What were we?
That's that, and we're good.
Yeah, that looked like a satellite dish. So if this one has kind of scooped out on the other side, maybe that would give us a clue if it's the same or not.
The two laser beams you see here, we use these as our measuring devices. They are 10 centimeters apart, and so we just had those beams on the sponge to give you a sense of scale, which is very hard to do. We were quite surprised when the samples came up yesterday how small they were. But, you know, 10 centimeters.
Can we do a partial on the other side video?
Across. Here we go, yeah.
Looks similar to the one we sampled yesterday.
And these rocks, these pebbles, they're like almost like nodules. You can tell they've been rolled around, and the black surface of these is an precipitation out of the seawater of probably manganese and iron. We saw this yesterday as well, and it's really a crust on some other surface.
All right. Let's rotate center.
Yesterday's rocks, when we broke them away after recovering them, the crust was just a few centimeters thick, completely surrounding any exposed surface that had been
267 copy.
So we could come a little bit forward if you wanted to line up.
Basically oxidized and then precipitates formed on top of it.
Sonar.
Yeah.
The size of those pebbles indicates a pretty strong flow of current at some point that must have brought those pebbles down through this area, and we had a shadow effect of that sponge, and so behind the sponge they got left behind as the currents whisked away any others around to either side. So we often see that. You can see even on beaches on a smaller scale.
We have about another minute left in this swing.
Copy.
So if you want to get another one out there, we can. You're approaching whatever that target is.
Yeah, we can reach it then.
Okay. And Nolan in the chat room said that he does think that this might be the same genus of sponge we were seeing yesterday, Ficalia. It's a demo sponge. And then Tom pointed out that there's a cavalindid test near the base of that sponge.
Yeah.
Oh, it's a decent sized rock.
Like we have some more barnacles.
Yeah, more gooseneck barnacles, and I don't know if that's a worm tube that they're growing on or a dead coral.
Maybe I come back up.
Or marine debris. Hopefully not.
Could be marine debris. Unfortunately, we did see quite a bit of marine debris yesterday, even at 1,600 plus meters, which was surprising.
Going back.
I think the left-hand edge shows a white
hard to tell, isn't it?
Yeah, there's something fuzzy on there.
Maybe zooming in on the end of the black stalk.
Oh, this is the barnacles up there.
Go ahead, Bridge.
Also looks like there's some hydroids on the black stalk.
Excellent, thank you.
Those are the small organisms in between the barnacle clumps.
All right, video whenever you're happy. Great. Looks like we have more targets up ahead.
Yeah, there's one right there.
Oh, yeah.
Here.
Nice.
That's what we're looking for. So it's likely that this entire region has the types of rocks that we're approaching, probably just underneath this sediment veneer, which is why we get a strong backscatter return. So it's
you can see a little purple
gratifying to finally see some rocks
the lasers, maybe it's just
along with some of those nodules or pebbles that we encountered earlier.
And come back out.
See a very interesting sponge here. Several sponges, different species.
Yeah, it's a different kind of sponge.
Growth or something, yeah.
What if that is indicative of the current direction, the shadow of sand and rocks.
That makes sense to me. I think that's right. It's, well, relatively downslope.
Yeah.
The ROV is currently heading into a northwestern
same thing, 30 meters.
orientation.
Yeah, I think so. We're 45.
So we're kind of looking into the current here almost. You can tell by those deposit trails,
Okay, why don't we start with the 30,
which are now under the ROV.
Yeah,
so we're heading into the current.
Something translucent between that sargassum.
What do you want, 240 where you're facing now, or still 255?
Right there?
Yep.
All right, go in for it.
Go by
This rock seems to be quite different from what we encountered yesterday. Much blockier.
Bridge, RV now.
And looks a lot more cohesive than what we saw.
30 meters at 245.
And there's more sargassum there, but that looks like a glass sponge in the middle.
Good copy.
And a few brittle stars.
All right, video whenever you're good.
Copy.
Can we get a close-up of that surface of the rock right above? Yeah.
Right there. All right, video, come on in.
The darker areas. Just a little down, yeah.
Rock or sponge?
So I wonder if the biology is getting in the way of the rock here.
It is, but that's all right. We want biology on the rocks. That's the whole purpose of studying this area, is to find who's living on the rock exposures.
Hi, Leslie and Cheryl. It's Scott France. Looks like an encrusting sponge here.
Mm-hmm.
Yeah, that's what I was thinking.
There's some interesting little volcano kind of sponges.
It looks like a white,
darker surface.
White tube worm on the right there.
Yeah, I can't tell. Is that a tube worm or is that a carnivorous sponge?
Oh.
You may have a better angle at it than me, but if it's got a whole bunch of like side bristles, that may be a small cladorized sponge.
Oh, that would be exciting.
Should we try to move in a little closer? Pilot, could we inch forward a bit?
What do you want to focus on, Watchley?
Maybe not.
Do you want the white?
Yeah, the white
Copy that. Video
tube-like thing.
There's one on the left.
We're going to try. Well.
There's another one on the lower left. I'm pretty sure that's what they are.
Fishing tail.
These would be sponges that have an entirely different biology from the typical sponge, which the typical sponge, like that large globular one we're just passing over, will basically suck water into the tissue and remove food particles from the water. But cladorhizids actually have structures, spicules, that are formed like hooks, and they capture small plankton, and then the cells can migrate over the body to cover that plankton, and then they digest it. So an entirely different mode of feeding.
That's really interesting.
We've
now,
heard.
Getting close to it, I can see this is not a sponge.
Oh, okay. Well,
it has polyps. I think this might be a bryozoan.
Wow.
Doesn't that look like it's got a whole series of polyps sticking out?
Yeah, it does.
Or rings of tentacles is what I should say.
Yeah, I can see them now.
Yeah. And the structure is such that
it does look like one. Yeah.
Can we kick on the extra lights?
So that must be a bryozoan.
This subject?
Process of elimination.
There you go.
Yep, and we have other people in the chat room agreeing that's bryozoan.
Yeah, great.
And then
that's an excellent zoom. Thank you.
Look at the white stones. Yes, thank you, pilots.
Yeah, great. Video whenever you're happy.
So to the right, so we're on the lee side of the current here. You can see the particles flowing.
Watch, is anything in view?
We should probably look at some of these other globular types of sponges.
All right. Anything specific? Or?
Let me know when you start moving.
Scott, would you like us to zoom in on any of the others?
Co-pilot.
I know Shirley would love you to zoom in so that those sponges can be looked at in more detail later.
We might need to reorient because of these rocks, but
I agree. It looks like there's at least
could leave it on already.
Here, those
close.
Watch
kind
it.
of
Any of
bluish
the next
encrusting ones
target
that we were looking at a moment ago. That very large yellowish beige one, and then the smaller pincushion-like white one.
Watch, the ship's about to... Okay.
Is it
I think I'm just
this one?
starting to move.
Center?
Andy.
Okay.
Yeah.
Then we have...
Video, give me one
That's
sec.
only 5 minutes.
Okay, maybe I'm not moving then. That seems too short. I'm not going to touch my rotator and I'll see how long it takes for D2 to move.
Copy that, thank you.
Your video come wide a sec. Let me get a tow real quick. Kind of broadside of the current there. It's hard to float.
you can almost feel the current watching it. You see a shrimp holding on for dear life there.
Backside.
Yeah.
And do we already have a view of what all that
stuff
is that's sticking up to the left of the shrimp? Looks like a bunch of...
No, I don't think we've gotten there yet because that's right in the current. But we'll certainly take a look. And it looked like there were some brittle stars on that larger sponge, maybe even a sea star.
So I am not a sponge expert. We would need a sponge expert here, but I'm guessing this is a demo sponge, so not a glass sponge, and I'm saying that just based on the appearance, the texture, if you will, of the sponge. And even those two yellowish things to the right, those may be another kind of sponge or tunicate. I can't quite tell. They're so small, but probably sponge. So I think that's a pretty good view for us.
Video is
clear.
And when video's happy with what they have, we can.
Okay, you gotta be starting to move now, right?
Yeah, I think so.
Okay, so we'll say 7 minutes.
Fish is up to your port. Not worth spinning for, but
Furry stuff. Copy that. Copy. Alright, video, come one sec. Let me find a nice equilibrium point.
Definitely a dynamic area here. We're seeing a lot of scour areas from the currents and deposits of large debris. Now we're looking at the side of these rocks that are facing into the current.
I do see a little amphipod stick in the foreground. We were mentioning this yesterday. You see this thing that's kind of waving around on a thin thread, and there's something white at the end.
Or rotator, excuse me.
Sort of moving off like a flag to the right. There's an amphipod, a little crustacean, on the end of the stick, and I believe it creates that stick itself. I'm not sure what's created all the other sort of brown branching stuff. I'm guessing those are hydrozoan colonies, hydroids. And, of course, that sponge in the background, which looks similar to what we were just looking at earlier.
Wow, that's very interesting about that amphipod. You have great eye to be able to see that, and I'm sure we wouldn't notice that at all without the great video that we have here.
I haven't gotten that giant sponge yet.
Ooh, sorry, it's time to move on. Ship's starting to get ahead.
You can see with those two lasers being 10 centimeters apart, the size of my hand, that stuff we were looking at was pretty small. Amazing technology here.
Yes, very much so.
Any sonar targets? Looks like
we got a couple more. We had some out there when he was facing the direction of movement.
Okay.
There's something. There you go.
Additional life forms.
From the chat room, people are identifying it, that amphipod as a podocerid amphipod.
And Charles Messing suggests that agglutinated forams, foraminifera, perhaps Astorhizacea. Never heard of that one, Charles, and I actually knew something a long time ago about benthic forams.
Oh, yeah. Possible
those single-celled organisms that it's hard to believe they're single-celled when they form these agglutinated structures.
Later today.
Yeah.
Yeah, we're going to do some water transects today.
It's true.
We'll be here for that,
transect day.
That's correct. I'll be your navigator, right?
I'll be your co-pilot.
Copy that.
Yeah, watch it. If you see anything specific, just let me know.
Roger that. Thank you.
Would this be a granite type of rock?
That's some very angular rocks sticking out there.
I'm not sure what these rocks are. I'm hoping that maybe Jason Chater can give us an idea. But they certainly are blockier than what we saw yesterday. They're more lithified, meaning
octopus.
I believe they wouldn't fall apart when we tried to pick them up. They'd maintain their characteristic.
Where's Alexis?
And what we found yesterday are mudstones, and Jason Chater is suggesting that they are mudstones as well, but these would be more lithified, meaning that the grains are actually cemented together so that they don't fall apart. We'll try to get a sample, but certainly none of these are going to be able to fit or be even possible to pick up. So we'll keep an eye out.
If you guys were lucky enough to be watching the Sirius view about 45 seconds ago, a very small Dumbo octopus flew through Sirius's camera.
Capture it.
All right, when was the last move put in?
The last move was put in at 58 and finished at 02, so it should be just wrapping up with Sirius right now.
Copy that.
So if you guys are ready, I'll go ahead and put another one.
Crab coming next to laser.
You want another 30 meter move in?
Yeah,
you got a guy that's going on screen right down there.
So we've seen
small guy.
Yeah,
we've seen some interesting things.
Do you want another 30 meter move?
Not out of the front video camera on the dive so far, but we just saw it from the Sirius view. Looking down at D2, a Dumbo octopus swam by.
It's going to be
earlier
30 meters at
when we were descending,
2, 4,
there was a
5,
billfish, a big swordfish that swam through between D2 and Sirius. So yeah, it's interesting what you can see in the upper water column. And we had a long conversation yesterday about swordfish encounters with ROVs and submersibles, and it was amazing how many scientists had seen that happen. And I guess in the Alvin submersible many years ago, decades ago, a swordfish actually got stuck inside the outer coating of the Alvin, so they actually had a sample that they didn't intend to collect on the Alvin.
Great little hermit crab. You can see his shell is from a dead mollusk, a dead gastropod. And an anemone has also taken hold on the other side.
Video's clear.
All right, good. Come wide.
Actually, Tom, I'm not sure how to pronounce your last name, but we heard actually was a tunicate on the hermit crab. Thanks for clarification. Oh, we're having chat room back and forth, and now I am told it is an anemone. Thanks, Tina.
Watch, this is nav. Watch leads nav. Hey, just letting you know that we're about to cross the 100 meter, first 100 meter.
Nav just let us know that we've gone 100 meters since we started this transect. Our current depth is 3,412 meters.
And we are heading north-northwest along a gently sloping edge of the Blake Ridge. I almost said Blake Escarpment because that's where we were yesterday. Almost half of our sites begin with Blake, it seems. It's all part of this giant Blake Plateau feature that extends off the continental shelf off the southeast United States. It's part of the continental margin, and the Blake Plateau itself was formed millions of years ago as a shallow carbonate platform similar to the Bahamas today. And over time it sank to its current depths. The platform itself is ranging in depths from maybe 400 to 1,200 meters. And then on its eastern edge begins to descend much more rapidly along a feature we call the Blake Escarpment. And yesterday we dove on a portion of that at a depth of 1,750 meters roughly. And we have since moved out farther eastward onto what is known as the Blake Ridge. And it's a very, if you look at your Google Earth maps of the seafloor, you can see a very large triangular feature that has a ridge to it. And we're on that feature today.
To pirouette around
and it looks like we're coming into some more rock outcrops.
You'll start moving in about 2 minutes.
Maybe a sponge.
Maybe 3.
Right there. All right, Washleads, that's just out of reach right now, but we're moving that direction, so we'll just keep going, explore the other closer regions, and we'll make our way there.
We will get to that rock and to the sponge in a moment. We are
it's like 10 degrees port.
Yeah.
Orienting the ship and the ROV so we can get to it. So we'll just keep looking around here until we're ready for that.
I did notice it flickered.
No, there's no correlation there.
Oh, I think motor noise is killing the video signal. Watch.
Now restart that. Restart the camera.
Well, it came back.
I know, restart the camera.
Why?
I'll turn it on again. Because it's
looks
never
like
gone
another
out for me for
sponge
hydraulics.
on that one small piece of rock.
Any interest?
Just out of view now.
Should we take a look at it? It's a little different, I think,
That
from
happened
what
when
we've
you
seen
ramped up that
while
time?
we're getting oriented.
Yeah.
Sure, if the pilots can do that.
Yeah. All right, video. Give me 1 sec. All right, co-pilot, kill lasers.
Add extra lights.
And come on in.
Johnny, you okay with me turning lights on and off?
Yeah, you have full permission to adjust lights.
Copy.
More sargassum at the base of the sponge.
2 fish behind Sirius now. Just hanging out.
It's interesting to think about the sargassum down here, 3.5 kilometers from where it actually lives, and serving as a potential food source for the organisms living on this deep floor.
Yeah, it's more plentiful than I thought it would be.
I think there's just the 2 fish.
Yeah, I agree.
You may want to spin around and look, see what that is behind you.
Behind D2.
I think we really need our sponge people
fish,
today.
One left, one right.
We sure do.
But I think I'm worried
that paper that I was referring to before said that the sponge diversity, or not necessarily the diversity, but the sponges were extremely abundant down here.
I'll turn left.
Probably also need to tilt your camera up, I suspect.
Your fog lights are still on.
You want them on?
Yeah.
Well, that'll change that a little bit.
Yeah. Now there's one down at the surface.
There he is. Can we get lasers clip on it? It's very dusty though.
There's somebody curious to see us.
All right.
I won't even attempt to identify it.
Video, kill dust.
My first impression is it's a rat tail, but I doubt everything's a rat tail down
there.
there.
Got it. Ooh, video, he's...
Oh. I think you may be right on your first
Oh, really? All right, I'm going to quit now. Quit while I'm ahead.
There's a cleaner one still in your stern.
I think we rise a little bit.
Yeah, if you back up and rotate right.
It's kind of this dust bowl.
Can
we go for another video? What's that?
Yeah, that's nice.
You think fog lights would be good?
I don't know.
Very nice.
Maybe.
I suspect it'll blow out with the dust, but try it.
So Ken Sulak was chatting with us yesterday, and he was talking about the places on the fishes that are important to get zoomed so that they can be identified later, and those are the shoulder region and all of the different fins.
Yeah. All right, video come on.
So I think we got some nice video there.
Kind of drifted. The center.
What was that last direction movement? 250 or something?
245.
Which rock?
Try the hydraulics again, and we'll see if it keeps doing that. Copy that. Thank you.
Hold on a minute. No, I'll tell you what. Keep plugging me.
Which rock? The small one with the sponge? Was it in the distance? Oh yeah, we're just waiting for the ship to move there. Yeah, we're moving that direction. Yeah. No, that's all right. I actually think we're approaching it right now.
Yeah, it started at 15:10, so we should be good out there.
Great.
We got a glimpse of this earlier, but had to reposition the ship.
I bet that fish follows us all day.
Would give us a longer period of time that we could stay in one place.
Yeah, we had questions on the Reddit Ask Me Anything question group yesterday about our experiences with submersibles versus ROVs. Leslie and I both worked with the Johnson Sea Link submersible a decade plus ago, and now have worked more with ROVs, and there are pluses and minuses to both. The submersible, you're personally there on the seafloor, and there's just nothing like that. What you can see with your own eyes down here is just amazing. you're more limited with bottom time with the submersible.
Significantly more limited.
Yeah, so you have 3 or 4 hours on the bottom, maybe, versus 6 or more with an ROV. And actually, we could even stay down for days with an ROV. The battery life of the sub is one of the things that really limits it. It's time on the bottom, and also the life support for the humans inside. But the ROV, one of the things that we need to keep in mind is that it is tethered to the ship, and so the power is coming from the ship, the video is coming back up to the ship through that tether.
Get some good zooms on this.
So we have to be careful about where that is, and we are attached to the ship. So if the ship makes a big move, the ROV comes along with it, and that has to be done very carefully. So the navigator from the ROV team is communicating with the bridge often to make all that happen
very clear.
Smoothly.
All right.
These look familiar. We saw some of these yesterday.
Toshiwana.
What were we calling them? Satellite dish sponges. The one on the left.
Yeah, Ficalia was the genus.
And clearly they're oriented to take advantage of the current's flow. It's like a catcher's net.
That was an interesting little view, because I'm not sure if that was 3 different sponges aligned in a row, or if it was 2 different sponges where one was just earlier growth states than the other. It's interesting to think about recruitment of these things and when the larvae settle, and what are the conditions under which a larva chooses to settle in a place, and then what allows it to grow. Obviously, there has to be enough flow of the water that there's for it to grow. But beyond that, is it just lucky where some larva decides to end up, or is it looking for something on the surface?
Yeah, copy that. Copy, I'll keep my eyes out.
Yeah, for each species that could be different, and it could be something about the microbes that cover a structure. It could be something about the type of geology that it is. And then the position in the water column. If organisms can be higher in the water column, they're likely to obtain more food that's passing by with higher flow.
Can you look just below the lasers? Is that I saw something protruding from the sediment, and I couldn't tell if it was creating a circle
out here for another second.
Which means it could have been a black
so the last move started around 10 and ended about 10 minutes ago.
You should listen to Scott France.
Yeah, Washley, go ahead.
And it was before we zoomed in.
Yeah. Video come wide, looking for a scour mark.
Are you seeing it, Scott?
No, you're too zoomed in. It's before you zoomed in, so it's going to be back a little bit.
Okay, we're zoomed out now.
All right. It's probably right where the lasers are now, and I'm not seeing it. I think it's right below, well, I'm 7 seconds delayed, but it's in that pit where the lasers are immediately to the left.
Okay, I see something there.
Emerging from the sediment. And I'm just wondering, is that a worm tube or is that a coral?
Pilot, could we zoom in just a little bit below the lasers, please?
Yeah, video going. Is that what you want?
Yep, that's it. Thank you.
All right.
Those look like tubes.
I think I saw a white anemone underneath that ledge when you were zoomed in before. Yeah, so those must be polychaete tubes, I imagine.
That's what I was thinking as well, yes.
Yeah. Okay, thank you.
Sure. We're good,
what
Pilot.
Thank you. What I had seen was the sediment around the tube. You can kind of make out a circle. And when the currents get strong enough, it blows whatever's growing out of the center, and it kind of swings around and creates that circle pattern. And there's a black coral in which that's fairly common, schizopathies, and that would be an interesting observation, but that's not what that was.
Huh. I guess that there are many signs that the current can be pretty stiff here.
What kind of depth ranges
do you see the
bathypathes?
rocks or?
The schizopathies, actually, they're really deep, so I would expect to see them down here at 3,500 meters. Black corals are among some of the
just to the right edge of the screen, just above
and the
half
schizopathy
center,
is also interesting in that it does live in sediment.
Object.
It has kind of a hooked base to the bottom of the colony, so instead of being a holdfast affixed to a rock, it can anchor in the sediment.
The sea star clinging to a rock, or actually clinging to the sponge.
Yeah, I think that might be a sponge.
Yeah, yeah. But of course, the sponge is on a rock.
Right. It all comes back to the rocks.
All comes down to that.
And there's the dust for the sea star.
You'll need to get the sea star from the other side in here. You'll need to get the sea star from the other side in here.
Kind of scanning the area to see if we can find a loose piece of the rock, not the rounded rubble so much, but the squared off pieces that might have fallen off this ledge, but I haven't really identified anything yet. Instead, we might want to take a biological collection here that would include the rock on which the organism sits. I don't know.
Yes, that would be ideal, is to get a 2 for 1.
Yep, or 3 for 1, or more.
Yeah, I just had an email from Chris Kelly, who's going to try to get into the chat room. He's having some problems right now, but he was suggesting one of the sponges that we were just looking at previously was Conolasma, and that the fish that we saw, the rat tail we saw, was Coryphonoides. And so it'll be great if he can get into the chat.
Is there any interest in seeing this sea star close up?
Video. You can do a snap zoom.
Great, thanks. Yeah.
So I wonder if that sea star is feeding on that sponge or simply perching on that sponge.
Yeah, sorry, video.
Yes, holding on for dear life. I love how they face into the current.
Some dust coming.
And Tom is noticing that there's a heart urchin test close by the sponge base.
Let me down.
They haven't requested look at that crinoid yet, have they?
Sorry, I'm back.
Have another piece of sargassum that just rolled past.
I haven't heard anything.
Just above lasers now.
Yeah, I see it. Nav, I think Watchley's calling you.
Watchley, were you calling me?
Just try to shake off some dust real quick before I enter.
I can't hear. Oh, yeah, now I got you. We can do our little method if you'd like. Okay. Hey, pilot, they're going to want to find out what the current is, so that means going off stick after I get into advanced mode.
Do you speed up?
Do I what?
Can you track it?
It's the
ROV velocity? Or what do you want to...
It's, hold on, I got to find it. It's expert view, there it is. It's... I think it's this one.
Our video snaps in?
Yeah.
Tell me when you're ready. We can do something.
Yeah, actually we'll probably just switch out and then do it.
It looks like a crinoid, perhaps.
Oh, yeah.
Beautiful.
So this would be a comatulid crinoid, common name feather star. You can see that it has these pinnule structures that it's using to grasp the rock, kind of like little legs or feet. And it has its feeding arms up in the water column. This is an echinoderm, so closely related to sea stars and brittle stars and urchins. And so in those arms that you see sticking up in the water, there are very small tube feet, and they use the tube feet to flick their food out of the water into a groove on the arm, and then the mouth is down in the center of those arms. And clearly the current is pretty strong, moving from right to left.
Yes, we're currently facing northeast, so the current seems to be more northwest. I'm sorry, southwest here. No, I'm sorry. We are facing northeast, so the current would be flowing at right angles to that. So right in this area, more to the northwest. But we are checking on the current velocity and should get a better hold on all that. If you're just joining our live feed, we are on the seafloor of the Blake Ridge, which is, we're about 300 kilometers offshore of Charleston, South Carolina, in water depths. Right now we're at 3,400 meters.
What are we getting for readings? Okay.
We're doing a pilot change here, so won't be zooming for a little bit until everybody gets settled. But we're coming over some more good habitat. So.
You can see our skid mark from when we sat down earlier and looked at these sponges on the rocks in front of us. We were hoping to get a rock sample, but now we have a pilot switch, so we may have to move on to the next site because we can't stay in any one location too long because of the ship overhead starts to have to move position.
Sorry, at the handoff there, they told me that you guys wanted to quantify the current. So that's what we were doing, is trying to quantify the current. But I heard you wanted a rock sample instead. Okay. Okay. All right, Bobby, you've got the expert view up there. So if I get a little ahead again and let myself drift, then still get that. I think they said
actually,
they did.
Nav? It was passed off to us that you were looking for a current measurement. We can stop our motion and let the current take us and calculate a reading, or I'm sure the pilot can kind of give you an estimate once he flies around a little bit, but that would allow us to kind of continue motion. Which is your preference? Okay.
And Charles Vessing just let us know that this is a depth record for a feather star on the Atlantic. Maybe. Thanks, Charles.
Maybe
we'll go for another 10
quarter knot.
Oh, that's exciting.
Yeah, it is.
Yeah,
some of the he writes some of the swellings of
not
pinnules
super high, but more than typical.
are gonads.
Quarter knot.
This is the family, and Antodonidae.
Are we moving?
This family has been broken up.
Ship is not moving.
All right.
That's sad. The family was broken up.
I think in this case it just means that they're not taking children from the families. But yeah, they come out in different clades, so they're probably named
okay, how long has it been?
in the same genus when they shouldn't be
Blue
different
was at
species.
15.
Yeah, we should be pretty stationary
15:10.
Okay.
So
yeah,
we're
should
getting
get one going then.
an approximate read of the current
They
speed
said they were
by the
going
pilot.
sort of southerly
245.
to chase the rocks, but I think we can start heading waypoint 2 if you want. Whatever ways.
Roger that.